Hello friends, let's talk about matching of orders now. But before that, let's revise our data structure that we are using. So we are maintaining two priority queues for both bids and asks, and buys and sells. So one priority queue is maintaining all those price levels, and at the head of it, for example, say for price level priority queue for all the cells that we have, the lowest cell price would be having the highest priority. So that would be at the head of this priority queue. Similarly, for the bids, the one with the priority queue is again a priority queue, and one with the highest price would be at the head. So this is how we are maintaining our both price levels for bids and asks. Similarly, for each price level, we are maintaining a map with key as this price and the value as a doubly linked list, which we are customized this as order list, in which the head, this is the head of this doubly linked list, this would be having the highest time priority. I mean, the order which has got which got the lowest time would be having a higher priority as per our like price time priority algorithm. So at the head of this doubly linked list, the head would be containing the best time priority at the same price. And this would be our algorithm that when we match the orders, we will use this concept of having of matching based on the price and time priority. So let's go off with our actual code algorithm. So I will go here, match orders. So we are actually trying to like find whether once we receive an order, we will see that whether we have got the price match or not. For example, for any price match, if we receive a buy order and the buy price is greater than or less than the best sell price that we have, then there's possibility of matching. Similarly, if we receive a sell order and if the sell price is less than or equal to the best buy price that we have, so in that case, the match is possible. So this is what we are doing. So suppose I have got a buy order, and now I want to see whether there's a matching possibility or not with the opposite side sell orders. So this is where I'm going to doing this check is price match. And whenever I see a buy order, I will always take the priority queue that we have maintained for the sell price levels, and vice versa. If we receive a sell order, then in that case, we'll try to see the opposite side, which is the buy price levels. So suppose let's take an example that would be easier to understand this. So suppose I got a buy order. Now I want to see whether it's a match or not. So then I will first of all take the sell price levels, which is our sell priority queue. And if I go to this is price match method, I will see that whether we have got any sell orders available or not. And if it is available, we will check the head of it. Because as I mentioned that we are maintaining at a peak, this is like O1 of time complexity for a priority queue. It's O1 only, constant time. So once we get the top price, which is there at the sell price, which is the minimum sell price that we have available in our priority queue, only then the match is possible. If our buy order is having a price greater than the top price, only then the match is possible. So suppose if I got a buy order of say 20.25, exact same. And so what I'm doing is in the code, I'm checking this sell price level priority queue, and the peak method, which is O1 of time constant, it will give me that, okay, we have got some orders at this price level at 20.25. So it means that there's a possibility of matching. So this is what the priority queue peak method is doing to fetch whether the price are available or not. Now, once we get the match price in this scenario, then I told that we are actually maintaining this map in which at this price level, there's an order list, which is a doubly linked list, which contains all the list of orders with the time priority already set. So first of all, I will get this order list, and then I will try to get the head first, because this is the order which is having the best time priority at that price level. So every time when I'm trying to match, I will always get, I got a price already. Now I'm trying to check which is got the best time priority also. So this is when I get the order, opposite order. And then as we discussed previously, that we will take the fill quantity, which is the minimum of both of the buy order and the sell order, that for our example, and then we will fill with the minimum quantity for both of it. And as soon as we find the fill, and if we have consumed all this opposite order, then we will look for the next entry in the head, because the next entry in the head level would be the next order, which will be the best time priority at the moment. So we'll keep on consuming it like this, and then the way until we exhaust all our current buy order, we'll keep on filling it until we consume the whole buy quantity, or until we exhaust all the sell quantity, and then we'll move to the next price level like that. So this is all the algorithm that which is doing. So for example, if we have got a sell quantity which is still left, although suppose I have got a buy order of say 100 quantity, and a sell quantity which was there, which was matching of 200 quantity. So then it means that only 100 could be matched. Buy order is exhausted, and we have got still 100 quantity left for the sell order. And if it's greater than that, then we have to again add it back to the head of the opposite order. And again, adding head in a doubly linked list is again O1. So by maintaining this doubly linked list, one thing is guaranteed, that whenever we try to get the head to match here, that is also O1. And once we add the residual quantity of the same order, then we add it back again at the head, because still it has got the best time priority in our order list. And if we have already exhausted everything, then we simply remove it from our order cache. If at the same price level, if we have exhausted all the orders of the opposite order, then we'll remove this particular opposite order ID by using this ID. Now let's understand the code with an example. I think that would be the easiest way to understand this algorithm again. Suppose I have got an order book like this, in which I will just ignore this 20.25, and just we have got this sell price level at 20.3, and we have got two sell orders. One of quantity 100, which has got a better time priority, that's why it's at the head, and the other one at 905, which is the tail of this order list of 200 quantity. And suppose I have got a buy order of say 400 at 20.3. So in that case, we will see, as per our algorithm, we will see that whether we have got in our sell priority queue, we'll check the peak, we call the peak method. And there we will see that, okay, we have got this peak price of 20.3, which is exactly matching with the buy price that we have got. It means that we can match this buy order with the sell orders that we have at this price level. So once we get this, we will, using this key in the map, we will take out this order list, which contains two orders, one order at the head with the better time priority order 1, and the other one at order 2. Now we will have our first fill with this quantity 100 of sell and this 400 of buy. It means that the first fill generated for both buy and sell would be of 100 quantity. And after this, we will remove this order because it has already been exhausted. It has used all its 100 quantity for the fill. This is totally filled now. This order would be removed from this doubly linked list, and now the order 2 becomes our new head, which means that this is the best time priority order available at this price level to be matched. Now, because only like 100 of this quantity, so there are still 300 quantity left for this buy order. So this 300 quantity would be matched with the 200 quantity of this next buy order, or this next sell order. So this order 2 is now matched with this 200 quantity with the 300 quantity. So it means that this is again fully exhausted. I mean, this is completely filled now, total fill now. And then we have to remove this. And then in our algorithm, we are also doing this check that if no order is left now, because both are completely filled, so it means that this price level would be removed from our map. So it will be removed from our priority queue for the sell orders. And also we'll remove this in the map with this key. We'll remove this complete price level. So this is how we are going to remove when all the orders are fully filled and there's no order left at that particular price level. But here we see that after all this fulfills, still 100 quantity of buy is left. Now for this 100 buy order which is unfilled, we will add it back to our priority queue now. So what we are going to do is that now we will first of all check this price level, like 20.3. So we will add this in our buy priority queue. So, and automatically whenever we add anything, because we are maintaining that this buy price is the highest price right now, 20.3 is the highest in our list, so it will automatically placed here at the top of this priority queue at 20.3. So our new price level has been created at the buy side in our priority queue, and after that we will add to our map as well, in which we'll keep this 20.3 as price, and the value of that map would be the order list or the doubly linked list, in which the head would be this order quantity of 100. So here there would be a new entry of price level at the buy side here, and here it will be having the price as 20.3 and the value as a doubly linked list of order 1, call it ID 6 whatever, and quantity of 100 and time, whatever the time the order has arrived. So this is how the whole algorithm is working, which I have put in the code, which we can see in the description. Let's quickly check the time complexity of this whole algorithm. So if we look at this while loop, because this is a while loop, that's why it would be ON. But if you look at the is price match, we are calling this peak method, and the peak method on PriorityQueue is always O1. So this is O1, and similarly, when we try to using the get operation on a map is again O1, in which we get the opposite orders or order list, which is a doubly linked list. Getting the head of this doubly linked list is again O1 for getting the best time priority order at that level. And similarly, once we try to match, it's all quite straightforward. And once we want to add it back to our doubly linked list for the unfilled orders, we have to just call add head, which is again O1, which is re-add to the front or the head of this doubly linked list. Similarly, from the map, remove is again O1. Remove again at for a whole price level key value that we are maintaining, that's again O1. Poll here is like log n. So this will only happen once we in this condition when the opposite orders are all empty. So only in that case we will call poll method on the priority queue, which is O log n. And similarly, once we have the quantity as 0, when we have to remove this order from the cache, again remove is O1. So if we see the whole algorithm, in the worst scenario, it would be n log n and log n. So n multiplied by log n for the whole matching algorithm. But this n log n will only happen when the opposite orders are all empty and when we want to like calling this poll method. Otherwise, in the worst scenario, it would be all on. So this is a much improved algorithm for our matching using our new design of priority queues for the price level and a key value map with a value as a doubly linked list. Our performance has improved from our previous implementations. And this, I would say, this is one of the like standard implementations I have seen across in most of the like cryptocurrencies or the exchanges that are implemented in the banks. So this algorithm for matching is ON. And I have written some test cases as well, which you can check later on. And I'll see you in the next video for covering the other cases like cancels and all. So see you all in the next video.